Okay, we have our Unit 7 and Unit 8 final exam review right here. So to start with Unit 7 was identities and solving. So on 1 through 6, you are proving the identity. So we're proving one side equals the other. All right, so you want to change the more complicated side to the other side. So I want to change this side so it looks like this one, which means this one never changes. That was a big thing when you took this Unit 7 test, is you guys kept trying to change both sides, one side at a time. All right, so I'm going to change this side, and I know from my identities that cosine squared is 1 minus sine squared. Okay, and I'm going to leave this one as it is, so bring it down. Okay, keeping the right side alone, I'm not even going to touch it. So then on the left again, I have 2 of these. So 1 minus 2 sine squared. Well, that's what I have. So did we prove that the left equals the right? Yeah. Okay, moving on to this one. We want to change the more complicated side to the other side. And remember, it's one side only. This side is more complicated than that side. Okay, so I'm going to change cosecant. One rule that you can always follow is try to change to sine and cosine. So cosecant is 1 over sine squared. Tangent is sine squared over cosine squared. And then the sine squared cross cancels. You have 1 over cosine squared, which is secant squared, which that's what we have over here. So you've proven that the left equals the right. All right, the easiest way to do number 3 is to recognize your Pythagorean identity right here. Secant squared minus tangent squared is 1. And 1 over cosine is secant. Okay, if you don't recognize that, then you would change secant to 1 over cosine. And you would change tangent to cosine, sine over cosine. And this is all still over cosine. And then you have common denominator right here. So I have 1 minus sine theta over cosine theta over cosine theta multiplied by the reciprocal. Multiply, we have 1 minus sine over cosine squared. Well, cosine squared is, what am I missing? Forgot the squares here, that's what's missing. That could change a lot. All right, so I fixed that. So that would make cosine squared times cosine, cosine cubed. 1 minus sine squared is cosine squared. So that's going to cancel, and that's going to leave me 1 over cosine, which is secant. So knowing your Pythagorean identities definitely comes in handy. All right, on example 4, you want to factor, because they have a sign in common. So pull the sign out. 1 minus cosine squared. 1 minus cosine squared is sine squared. And sine times sine squared is sine cubed, which is what I was asking for. All right, 1 plus cotangent squared over secant squared, and we're trying to turn it into cotangent squared. So 1 plus cotangent squared is cosecant squared. And then I changed cosecant squared into 1 over sine. Change secant to 1 over cosine. Multiply by the reciprocal. So we get cosine squared over sine squared, which is cotangent squared, which is what I was asking for. Okay, tangent theta, cotangent theta over cosine squared plus cosine squared over sine squared. Anytime you multiply a trig function by its reciprocal, you get a 1. And then cosine squared over sine squared is cotangent squared. And 1 plus cotangent squared is cosecant squared. Again, just remember as you do these, you concentrate on one side only. All right, sum and difference formulas. You have these formulas, you'll be given them, but difference formula for cosine. Cosine alpha, cosine beta, plus sine alpha, sine beta. So alpha would be your 5 pi over 3, beta would be 3 pi over 4. So it's a matter of plugging in. All right, cosine 5 pi over 3, again, unit circle value. That's quadrant 4, cosine's positive, and it's positive 1/2. Cosine 3 pi over 4, that's second quadrant, cosine is negative. Sine 5 pi over 3, that's second, fourth quadrant, but this time sine is positive, or negative. And sine 3 pi over 4, again, quadrant 2, but this time sine is positive. All right, and you can change this into one fraction. I don't have a preference. I think Lumen generally wants it like this. Okay, now sine 19 pi over 12, and you want exact values. Okay, I'm just gonna tell you that in directions, no decimals. So 19 pi over 12 is not a unit circle value. So we need to use our unit circle values. And I'm gonna rewrite them so that I have a denominator 12. I wanna find a pair that adds or subtracts to 19 pi over 12. So we think of pi over 3. If I put it over 12, it would be 4 pi over 12. Okay, pi over 6. That would be 2 pi over 12. Pi over 4 would be 3 pi over 12. Those are the first three quadrants. No, the first quadrant. And our remaining here, the adds to be 19 pi. So I'm gonna try pi over 2. Not quite. I'm gonna try 2 pi over 3. Okay, I'm gonna try 3 pi over 4. Nothing yet. I'm gonna try 5 pi over 6. There it is. When I add those two together, I get 19 pi over 12, which means my alpha is 3 pi over 4, and the beta is 5 pi over 6. So sum formula. So we're changing this to 19 pi over 12 to not 3 pi over 4 plus pi over 6. Then your sum formula, sine alpha cosine beta plus cosine alpha sine beta. So at this point, I'm just plugging in. Sine of 3 pi over 4, that's positive root 2 over 2. Cosine 5 pi over 6 is negative root 3 over 2. Cosine 3 pi over 4 is negative root 2 over 2. And sine 5 pi over 6 is 1/2. All right, I have the sine of the inverse cosine of something minus the inverse sine of something. All of this, that's an angle measure. When you're taking the inverse of something, it's an angle. So this is an alpha. All of this, because I'm taking the inverse sine of something, is an angle. So that is your beta. So I really have sine alpha, try that again. Sine of alpha minus beta, which there's a formula for. Sine alpha cosine beta minus cosine alpha sine beta. So now I need all these pieces. So let's start with the yellow. Inverse cosine of negative 5 over 13, which means the cosine of some angle, I don't know what it is, equals negative 5 over 13. Cosine is x over radius. I'm eventually, let's use alpha instead of that. I'm eventually going to need the cosine of that, which means I need, or a sine of that. I'm going to need the y. So x squared plus y squared equals radius squared. So the y is 12, which means sine alpha equals 12 over 13. All right, now we do the other one, the green. So inverse sine of 3/5 would be the sine of some angle equals 3/5. And that's y over radius. We eventually need cosine beta. So I need the x. X squared plus y squared equals radius squared, which means the x is 4. So cosine beta, 4 over 5. And now I can go back and plug in. Sine alpha, 12 over 13. Cosine beta, 4 over 5. Cosine alpha, negative 5 over 13. Sine beta, 3 over 5. So we get 48 over 65 plus 15 over 65, which is 63 over 65. Okay, tangent 7 pi over 6 minus 2 pi over 3. It's alpha and beta. This has a formula. Tan alpha minus tan beta over 1 plus tan alpha tan beta. All right, so I want the tangent 7 pi over 6, tangent 2 pi over 3 over 1 plus tangent 7 pi over 6 times the tangent of 2 pi over 3. Okay, tangent 7 pi over 6. Guys, we talked about this on the review for units 5 and 6. Okay, that's one you have to know. 7 pi over 6 is in quadrant 3. Tangent's positive there. So this is positive root 3 over 3. Tangent 2 pi over 3, that's quadrant 2. Tangent's negative there. And for your pi over 3s, your tangent is negative root 3. All right, so I'm going to concentrate on this bottom one real quick. When I multiply those two together, I get negative 3 over positive 3. Oh, that's 1. So I really have 1 minus 1. So I have all this fun mess up there in the numerator, but I have 0 in the denominator. So if you've got 0 in the denominator, that means this identity is undefined. All right, in this section, you're still using your sum and difference identities. Again, remember, you are given those formulas. You will have a formula sheet. You just have to know what to do with them and which one to use. So I'm asking you to sketch a picture. Let's look at sine alpha. So sine alpha is negative 4/5. Well, sine is negative in quadrants 3 and 4. And then it tells you that that angle is between pi and 3 pi over 2. So that tells me it's in quadrant 3. Okay, well, sine is y over radius. All right, so when we draw a triangle, we go out first, horizontal, then vertical, and then we connect. So we know that the y is negative 4, and we know the radius is 5. With this information, we can use Pythagorean theorem or know our Pythagorean triples. And we know this is negative 3. All right, so I'm going to go ahead and get the remaining trig functions. We have cosine alpha. So that's going to be negative 3/5. Then we have tangent alpha, which is going to be positive 4/3. So we're going to do the same thing with beta. Beta gives me cosine. Tells me that cosine is positive. Cosine is positive in 1 and 4. Well, then it tells me between 3 pi over 2 and 2 pi. So it limits it to quadrant 4. Well, cosine is x over radius. So we draw our triangle. Remember, that's horizontal, then vertical, and then radius. So we know x is 5, radius is 13. And using Pythagorean theorem, we know that the vertical is negative 12. So we can find sine and we can find tangent. All right, so we're using cosine alpha plus beta. So there's the formula. Again, you'll be given that. You just got to plug in the right formula, so the right pieces. And cosine alpha, negative 3/5. Cosine beta is 5/13. Sine alpha, sine, what am I trying to write there? Sine beta. And then, like I said, at this point, you can just type this in your calculator. You don't need to worry about trying to work it out, trying to get those common denominators, all that. So we get negative 63 over 65. All right, again, tangent alpha plus beta, there's a formula for it. You just have to know which tangent ratios to use. So this is the sum formula. We've got tangent alpha, which is 4/3. Tangent beta, which is negative 12/5. Minus tangent alpha, tangent beta. 100% a calculator right here. You're going to put this in. You're going to get negative 16 over 63. All right. So now we have sine alpha minus beta. We got the formula. You have that. Plug in the right ratios. We have sine alpha, which is negative 4/5. Cosine beta, 5/13. Cosine alpha. Sine beta. And again, that's 100% calculator at this point. And you're going to get negative 56, if I can even write it, negative 56 over 65. Okay, use double angles. Again, formulas you're given. to find the exact value of the following if tangent alpha is negative 4/3 and angle A is between pi over 2 and pi. That means we're in quadrant 2. All right, tangent is y over x. Jackson, I'm recording, babe. So x is going to be negative there. Y is positive, and we know the radius has to be 5. All right, so sine A would be 4/5. If I can write cosine A, oh my gosh, would be negative 3/5, and then we have tangent with negative 4/3. Okay, double angle for sine is 2 sine cosine. So plug in. That's going to give me negative 24 over 25. 2 times 4 is 8. Negative. Yep. Cosine 2a, there's 3 formulas. It doesn't matter which one you use. This one's the one I'm going to use. You can use your calculator at this point. And then tangent 2a. And tangent was given, so it shouldn't be a big deal to plug in. That's 24 over 7. You do not have half angles on this. So if you want to get this information, you can go ahead and pause here and get all this written down. But you do not have half angles on your semester exam. All right, find all solutions. I want you guys to highlight or underline all. All right, find all solutions for secant squared minus 3 secant plus 2 equals 0. First, this is quadratic. All right, the next thing I see is that it's got a linear part as well as a constant. So this is a quadratic function. Okay, so we're going to factor it like a quadratic. And think of x as secant. And so this factors really well into x minus 2, x minus 1. And then if I imagine putting the secant back as the x, I've got my factors. So your factors equal to 0. You're going to add the 2. Okay, secant we don't solve, we solve cosine. So that's a reciprocal. So if I take the reciprocal of 2, that's 1/2. So theta equals pi over 3 and 5 pi over 3. So it asks for all solutions. So this includes any kind of rotation. So pi over 3 right here. But I can rotate around and get there again. Rotate around and get there again. And again and again. So to show that, we say pi over 3 plus 2 pi k. 2 pi being a rotation, k being the number of times that you rotate. I'll do the same thing with 5 pi over 3. Right. Now we solve secant minus 1, so add the 1. Reciprocal. Between 0, we're only doing angles between 0 and 2 pi, not including 2 pi, because that's always already one rotation. So the only angle that has an x value of 1 is 0. And so we want all possibilities. And so there's all possible solutions to that equation. All right, secant squared theta plus 3 tangent theta equals 1. Okay, so when you have mixed trig functions, I have a secant and I have a tangent, you want to try and change them into another, unless you can factor. I can't factor this. So I'm going to change secant squared into 1 plus tangent squared. And since I do have that square there, that means this is quadratic. And I want this equation to equal 0, so I'm going to subtract the 1 as well. By doing that, I can see that the 1's cancel. And the remaining terms share tangent. So I'm going to factor out a tangent. Set them equal to 0. Again, it wants all solutions. So tangent theta equals 0. Tangent is y over x, so it's where the y is 0. And that occurs at 0 and pi. So for all solutions, 0 plus 2 pi k and pi plus 2 pi k. Over here, we're going to subtract that root 3. So theta equals, let's see, tangent is negative a quadrant 2, so that's 2 pi over 3, and 4, which is 5 pi over 3. So all solutions I want you guys to star this one. This is a big common mistake across the board on your Unit 7 test. All right, find all possible solutions for 8 sine squared theta equals 2. So we're going to divide by 8 first, which is 1/4, and we're going to take the square root, and this is where everyone missed. When you take a square root, you include plus or minus. All right, you have the positive 1/2 and you have the negative 1/2. So where sine is positive and negative 1/2 is all of your pi over 6 angles. So we have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. It does also want all solutions. So it's all these angles plus 2 pi k. All right, find all solutions for 3 tangent 2 theta minus root 3 equals 1. All right, so we're going to treat this as if this is, I don't have a 2 theta here. We're going to treat it as if it's just a theta. All right, so we're going to add the root 3. Actually, this should be 0. I forgot about that. And divide by 3. So then we're going to solve this. We're going to figure out all the angles that have a tangent ratio of root 3 over 3, positive. Okay, we're going to ignore the fact that there's a 2 theta here, but we're going to list those angles. So root 3 over 3, that's pi over 6. And 7 pi over 6. Now, this is where we acknowledge I do have this 2 theta. So we actually want to list out several rotations out. So one rotation out from pi over 6 would be 13 pi over 6, because you'd be adding 12 pi over 6. One rotation out from 17 pi over 6, or 7 pi over 6 would be 12 pi, 19 pi over 6. Do another rotation, so we're rotating out from this, so it'd be 25 pi over 6. And that's probably about as far as I would go. I just like to have options. All right, so now we go back and acknowledge that it's a 2 theta, not a theta. So if I wanted to get rid of the 2, I want just theta, I would divide both sides by 2. Okay, really that means we're going to multiply everything through by 1/2. Okay, and by multiplying everything through by 1/2, it multiplies every denominator. So theta equals pi over 12. Now at this point, you're looking for all the angles from 0 to 2 pi. So you want to make sure you don't go over 2 pi. All right, that one's too big, okay, because 2 pi would be 24 pi over 12. So this is not part of our solution set. Okay, so I have these 4 options. These are all the angles of 2 theta that give me a root 3 over 3. Now it says all gradients. All right, so theta equals pi over 12 plus 2 pi k, 7 pi over 12 plus 2 pi k, 19, I'm missing one, 13 pi over 12 plus 2, and 19 pi over 12. All right, identify all exact solutions on the interval from 0 to 2 pi. So I'm limiting the number of answers we can have. All right, so you're going to divide by 5. Okay, take the reciprocal and cosine. You're going to solve that as if you don't have the 2 theta. All right, so if I'm thinking, okay, what angles give me a cosine of negative 1/2? Those angles are, let's see, 2 pi over 3, 4 pi over 3. And because I do have a 2 theta here, I'm going to list a few options. All right, so I'm going to do another rotation around. So that would be 6 pi over 3. So that'd be 8 pi over 3, 10 pi over 3, 14 pi over 3, 16 pi over 3. Just do a few. All right, so this is where we talk about there is a 2 theta here. And I want to get rid of the 2. So we divide by 2, which means we're going to multiply everything through by 1/2. So we multiply everything through by 2. That denominator by 2. Okay, so we've got 2 pi over 6, which that reduces to pi over 3. You've got 4 pi over 6. That's 2 pi over 3. 8 pi over 6, which is 4 pi over 3. 10 pi over 6, that's 5 pi over 3. 14 pi over 6, so that's 7 pi over 3, which I'm going to stop there because 7 pi over 3 is too big. So my final answer are those 4 angles. Find all exact solutions on the interval 0 to 2 pi. Again, limiting our answers. This is quadratic because you have the 2 cosine squared, linear, constant. So this is a quadratic function. So we're going to factor it. And again, remember I do this by simply switching cosine to x. So I want factor pairs of -6 that add to be -5. And that's going to be negative, +1, and -6. So our factors are 2x plus 1, x minus 3. Set those equal to 0. So subtract the 1, divide by 2. That's going to give me negative 2 pi over 3. I think that's it for negative. If I go over here, cosine theta equals 3. Remember that cosine is x over a radius. This is 3 over 1. Radius has to be the biggest side. So this can't exist. All right, so you're not going to get any answers on this one. So my only two solutions are 2 pi over 3 and 4 pi over 3. Okay, on this one, all exact solutions, 0 to 2 pi. So honestly, the first thing I'm going to do is simplify this. You would have learned that in Math 1513. I'm going to find the biggest square that divides evenly into 48. That's 16. And the square root of 16 is 4. All right, so negative square root 48 is negative 4 root 3. Divide by 8. All right, so I want all the angles that have a negative sign of, has a sign of negative root 3 over 2. Well, it's going to be pi over 3s. So it'll be 4 pi over 3, 5 pi over 3, and then rotations. So 10 pi over 3, 11 pi over 3, 16 pi over 3, 17 pi over 3. All right, I'm going to get rid of that 2. Dividing by 2 is multiplying everything through by 1/2, which means you are multiplying the denominators by 2. That's what it means when you multiply by 1/2. 5 pi over 6, so that doesn't reduce. All right, that one's too big. So our only solutions, make that 6 look like a 6, are these. All right, this one's quadratic as well, so I'm going to go ahead and subtract the 1. And then factor it, kind of treating those signs like zeros, or x's. Group. Again, factoring is on your own. So I've got 2 sine theta plus 1 and sine theta minus 1. So your factors equal 0. See, negative 1/2 sine negative is 3 and 4. So it's going to be 7 pi over 6 and 11 pi over 6. Let's see. Y coordinate is pi over 2. All right, finally moving on to unit 8. All right, this is all your solving triangles. Okay, solve the triangle. If angle A is 115, side A is 32, side B is 15. So we draw our triangle. Angle A is 115 degrees, side A is 32, side B is 15. So we've got side angle. So this is law of sines. It is also the ambiguous case. You have the possibility of having a second triangle. Now, one thing that helps is if your given angle is obtuse, excuse me, you're only going to have one triangle. All right. So I'm going to start with this angle that I can find, and that's B. We're going to use sine 115 over 32, sine B over 15, cross multiply. Divide by 32. Okay. Now it's going to go in your calculator. All right, make sure that I'm in degrees, not radians. Radians. All right, so we're going to do inverse sine. Sine 115 over 32. And 25.140. So an angle C would be 180 minus the given minus angle B. $39.860. So the next thing we want to do is we want to find that missing side. And so only side we were missing was side C. So we're going to do sine 115 over 32. That's the side that's given. And we're going to do sine 39.860 over side C. Cross multiply. Divide by sine 115, excuse me. $22.629. I only have one triangle here because the given angle I have is obtuse. Triangle has side lengths 23 and 27, including an included angle measure of 146. Find the area. Included means angle between. All right, so we do have a formula for area. It's 1/2 base times height. However, I don't have the height. All right, so we use law of sines. Area is 1/2 AB sine C. So 1/2 23 times 27 times the sine of 146. $4 decimal places, so 173.6294. Solve the triangle if A is 17 centimeters, B is 33, and C is 19. So A is 17, B 33, C 19. This is side, side, side. This is our law of cosines. Formula to be given. So I don't have a preference what angle you start with. I just start with A. Inverse cosine. And you want the sides that are adjacent. So 33 and 19. Minus over 2 times both adjacent. What I wrote is what I typed, down to the parentheses and everything. So 22.2, 2 decimal, so 22.20.21. Now we'll do the same thing for B. And talking about the adjacents. What am I writing? This is the boring part where all I'm doing is plugging it in. 132.810. Now, how do we find the remaining angle? We subtract those from 180. All right, 180. It's 24.99. Okay, draw the vector -5, -8 in standard position. Means it starts on the origin. -5, that's the horizontal component, so I'm going to go left 5. -8 is the vertical component, so once I'm here, I'm going to go down and that point right here. So there's my standard position. Magnitude. Square root x squared plus y squared. So square root of 89. Direction angle. This is a reference angle first. And I know it's a reference angle because I can see that my vector is in quadrant 3. It was inverse tangent, absolute value, y over x. I'm just going to do that on my handheld calculator, not in radians. So this is our reference angle. Okay, it's not our actual angle. That 57 degrees-ish represents this. I want the whole thing. All right, so I need to add 180. So I'm going to add 180 to that. to 37.99. We'll do one more, 5. Okay. Vector 19, negative 17 has terminal point 11, negative 14. What is the initial? And our vector is terminal minus initial. I've got the vector. We're still missing the initial. All right, so in my head, I added the xy. And then subtracted this 19 at negative 17. So if I subtract 19, negative 8. If I subtract negative 17, negative 31. What a lie. No, it would just be 3. What am I thinking? And then we can always check terminal minus initial. That's negative 19. Terminal minus one day. Terminal minus initial. That's your negative 17. All right, find the area. Another side angle side situation. So I'm going to use area as 1/2. 29 times 21 times the sine of 22. Oh, 6, 7, 7. Solve for all possible triangles, ABC. If B is 50, A is 104, B is 40. Okay, side angle. This is law of sines. Cross multiply. And then we're going to take an inverse. You can write that down or not. I'm not going to, just, I don't know. Now, if I put this in the calculator, inverse sine 104 sine 50 over 40. We get an error. Which means we have no such triangle. A vector with magnitude 7 points in direction 190 degrees clockwise from the positive x-axis. That means it's 180 plus a little bit more. Magnitude is 7. Write the component form. So for components, I need x and a y. X equals magnitude times the cosine of your angle. Again, calculator. 190. This is 3 decimal places. Y is 7 sine 190. component form just means the vectors. I'm terrible at drawing that one. I always make that bottom curved. Close enough. Of all possible triangles. Awesome. Triangle ABC. Angle A. Side A. Side B. So because it's side angle, law of sines, and I have an acute angle, so I have the possibility of two triangles, so I need to find both. So we're going to find B first. So I'm going to do sine 42.3 over 187 sine B over 248.6. Cross multiply. Divide by the 187. I don't know why I did it on that side instead of the left side. That's okay. Take the inverse sine. I'm just going to do it over here. My handheld. 248.6 sine 42.3 divided by 187. So B 63.471 degrees. So C would be 180 minus the original minus B. All right, these are our possibilities. Let's go ahead and find side C real quick. Just a whole lot of writing. Divide. Calculator. Wrote 74. Wrote 77, but 74. All right, that's the remaining side. Now we find the second possibility for the angle. So to find B2, take 180, subtract B1. C2, 180 minus the given angle. Do we not know that? Oh, yeah, we do. 42.3 minus new angle B. And last, find your remaining side. 42.3 over 187. I honestly have no idea where my head is. 42.3, 187 sine 21.171. And we divide by sine 42.3. Pilot flying over straight highway, angles of depression to 2 mile posts that are 6.2 kilometers apart, 36 and 51 degrees. And why that's important is 36, 51. What is the elevation of the plane in meters? Okay, we want the height. All right, I'm going to go ahead and find this angle by subtracting the 2 that I have from 180. All right, I'm going to use these 3 angles. I have angle, side angle, which is sines. And I'm just going to use, I have to use that one because that's where I know both. And I'm going to use 51. So that means I'm going to find that side. Call it X. Divide by sine 139. Oh my goodness. I thought that looked too big. That's better. Same principle though. Cross multiply. Divide. I'm not doing great with this problem. There we go. All right, so the height comes from, comes from this guy. So I'm going to use a right triangle, specifically where the height is opposite, and I have the hypotenuse, which is the 4.825. So I'm going to use sine. Opposite over hypotenuse. We're going to solve both sides by multiplying by the 4.825. All right, now I did one in meters, not kilometers, so I'm going to multiply that by 1,000. So the height in meters, 2,836.015 meters. area of a triangle. This is 3 sides, though. This is Heron's formula. So you need a semi-perimeter. Add up all 3 sides. Divide by 2. Then Heron's 20. 20 minus 16. 20 minus 14. 20 minus 10. It'll take you longer to type it in your calculator than it does to just work it out. Okay, we get area equals 69.282. Magnitude. That's Pythagorean theorem. So the magnitude of z equals the square root 1 squared plus 7 squared. So that's the square root of 50, which reduces to 5 root 2. Give the measure, find the length of side x. I have side angle side. This is cosine. So x equals square root. We have adjacent side, other adjacent side, minus 2 times both adjacents. This is a formula to be given. Times the cosine of 32 degrees. All in your calculator. X equals 11.891. This one's asking for angle A. All right, this time I have 3 sides. Still cosines. All right, so angle A, inverse cosine. I want the adjacent sides. Minus the opposite side. All over 2 times both adjacents. That goes in your calculator. Make sure that you are in degrees. Angle A, 38.213 degrees.